Greetings, students. This is Mr. Torgerson. I'm going to stuff Unit 12 review here. So first off, the test. It's 18 questions, 15 multiple choice, and then 3 right on. I intend to make the multiple choice 5 points each. And the right on questions 8 point each. So this review here is all right on questions, but it is separated into multiple choice, and I will try to point out as we go along here how the multiple choice is going to function. So just keep that in mind. So the first 4 multiple choice questions, they're going to ask you about these 4 items: amplitude, period, phase shift, vertical shift. In other words, they're going to ask you about A, B, H, and K. A, 4. B is 2. Now B is the period modifier. So the actual period is not equal to 2 here. It's modified by 2. The period for sine and cosine is given by 2 pi divided by b. So my period is 2 pi divided in half. Pi. Now again, if there's nothing in front of this x, or in front of this parenthesis, b is always at least 1, because having a period of nothing would mean a wave would be not a wave. It has to have a period. It has to have a distance between the middle and the middle, or the height, or the top and the top, or the bottom and the bottom of the wave. That's the period. Phase shift is h. Remember, it's just like the x minus h with point slope form, parabolas, same deal here. So it says minus pi over 4, but its phase shift is actually positive pi over 4. If it said positive pi over 4, I said plus pi over 4 here, it would be minus pi over 4 here for my answer for my phase shift. And the vertical shift is k. That's the value at the end, the vertical shift. So it moves up 3 from normal. Again, these are 5 points each. So that there is 20 points worth of questions. 5 points each question. And they're going to be multiple choice. All right, so in terms of how you can get this wrong, you can mix up the values. You can mix up the definitions. So you can put this one here, or this one here, or this one here. If you mix them up, you're going to get all 4 of them wrong. Again, it's multiple choice. Or you can forget that you have to divide 2 pi divided by b to get the period on sine and cosine. Again, for tangent, your period is different. It's pi divided by b, your period modifier. But for sine and cosine, it's 2 pi divided by. All right, next question. It's going to ask you about the period for one of the 3 basic functions. Sine and cosine both have a period of 2 pi divided by b. 2 pi divided by 1. 2 pi divided by 1. Why am I dividing by 1 here? Because b is 1. The coefficient of x is 1. Tangent has a period of pi. In other words, tangent repeats after just pi, whereas sine and cosine repeat after 2 pi in length. All right, so you will have 1 question, not 3 questions about this, but 1 question concerning what is the period of one of the 3 basic trig functions, sine, cosine, or tangent. There will not be all 3 of these in terms of the questions here. All right, along with this question, you're going to be asked about some of the basic things like finding the sine of a particular value or the cosine of a particular value. So like, what is the sine of pi, or the cosine of pi, or the tangent of pi, or what is the sine of pi over 2, cosine of pi over 2, tangent of pi over 2, or what is the sine of, I don't know, pi over 3, cosine of pi over 3, tangent of pi over 3. Sine, cosine, and tangent from that unit circle. There will be something that you're asked about that as well in this multiple choice section. All right, the next questions. 8, 9, and 10. Again, these are 3 points each, or 5 points each. So far we're up to 25 points. There's only 1 question here, and then they'll also do, and then we have 2 questions about the unit circle, as I was saying before. So this would be question 8. Again, it's going to be multiple choice. So looking at this one here, which parent function is represented? So this function starts at the top of its amplitude and ends at the top. So it goes top to top. of its wave. So this is a cosine. This would be best represented by a cosine. Now we can use sine and cosine interchangeably. However, when they start at the top and end at the top, or when they start at the bottom of their wave and end at the bottom of the wave, that's a good cosine function. That's a better function to use for cosine because top to top represents cosine best. For sine, it should be middle to middle, like number 12, middle to middle. Starts in the middle of its wave, ends in the middle of its wave, its first wave. So this would be better represented with a sine function. Anyway, so I would choose cosine here because it starts at the top and ends at the top. I would also choose cosine if it starts at the bottom and ends at the bottom of its amplitude. So I'm going to say cosine. Again, this will be multiple choice, 5 points. What is the vertical translation? This is asking you for where the center of the wave is, or what the value of k is. So it is centered where is what it's asking. So this value here is 1. Its maximum value, y value, is 1, and its minimum y value is -3. In other words, it's centered right here at -1. It's centered at y is equal to -1, and we can call that k, that value, that vertical shift. So we could say that's down 1, or that's k equals -1. That is the vertical shift of this graph. It has been shifted down 1 from a normal cosine graph. A normal cosine graph would have its middle of its graph at 0, at y equals 0. In other words, it'd be symmetric with the x-axis. The amplitude, again, is the wave height. The height between the middle of the wave to the top or to the bottom. Not the entire distance from bottom to top. That is not the height of the wave. That's double the height when you go from bottom to top, but from the middle to the top. So from the middle to the top, it's 2. Amplitude of 2. It's going up and downwards 2. And again, one of the ways you could mix this up is you could give me the entire distance from the bottom to the top. That would be 4, but that's not the amplitude. That's twice the amplitude. That is not the wave height. That's twice the wave height. The wave height is only 2. It's going up and down 2, up and down 2. That's its tallness. All right, again, that'll be multiple choice. So I'll have one word ask you what type of graph it is, another one word ask you the vertical translation, then another one word ask you the amplitude. 15 points. All right, question 11. The graph of y is equal to 4 sine of x minus pi over 2 will have a maximum at. Here I'm asking for not only the y value, but the x value as well. So let's concern ourselves with the y value first. The y value here, since it's a sine function, the maximum y value will be at the coordinates of this amplitude. So again, our value that our maximum is going to be at is going to be h comma k plus a, or it's going to be k plus a, my y value. So these all have a y value of 4. All of these options have a y value of 4. So that really doesn't help me. So I do have to actually look for the period as well. So what is the period here? B is equal to 1. So the period is equal to 2 pi divided by 1. The period is equal to 2 pi. So what I'm going to do here is I'm going to think about what the graph should look like. So a sine starts in the middle of its wave and ends in the middle of its wave. It has its start of its first wave in the middle, and then the end of the first wave in the middle as well. So it's centered at 0 because k is nothing. So this will be pi over 2, comma 0. That'll be pi over 2, comma 0. It's got a period of 2 pi. So I'm going to have 3 other tick marks here. And then my last tick mark is going to be 2 pi plus the pi over 2, the phase shift. So 2 pi times 2 would be 4 pi over 2 plus another pi over 2. 5 pi over 2 is that last tick mark. There it is. So the wave is going to go up, back to its middle, down, then back to its middle. So here is the wave. I'm asking you about this value right here. What is the x coordinate? So this is 1/2. This is 5/2. So now I'm considering what it's going to be for each particular tick mark. So this is 1/2. This is 5/2. In between 1 and 5 is 3, so this will be 3 halves in the middle one. And this one will be 1 half plus another half, 2 halves. So this will be 2 pi over 2, 3 pi over 2, 4 pi over 2. This will be 2 halves. In other words, my maximum value is at pi comma 4. Now, that is the actual approach that you're supposed to take with this algebraically. However, because I provided you options here, you can actually plug each of these 4 options in and see which one of them yields what y value am I looking for? 4. So I'm going to get my calculator out. I'm going to make sure I'm in radian mode. Right now I'm in degree mode. Deg. Well, I'm going to go back and change this to radian mode. I'm going to type in 4 sine. Let's see what types when we put in 0. 0 minus pi divided by 2. So I'm looking for an answer of 4 here. That's negative 4. This would be the minimum. So this was actually 0, negative 4. That was actually 0, negative 4. That's the minimum. Let's try the next one. 4 sine 3 pi divided by 2 minus pi divided by 2. Again, I'm substituting this in for x. I'm substituting the x in, and I'm seeing if 4 comes out. If 4 comes out, that's going to be the maximum. That's 0, like we thought it was. So that should be 3 pi over 2 comma 0. Next one. Going back up, substituting pi in. I'm going to delete the 3 and delete the 2. That's 4, just like we thought it was. And then the last one, I'm going to put in a pi over 2 minus pi over 2. That's 0 again, just like I thought it would be. At pi over 2, we're at 0, not at 4. So at pi over 2, we should actually be at 0. All right, so this question, there are multiple approaches to it. There are multiple approaches to this question. You can plug it in the calculator. You can plug each x value into the calculator here and see which one yields the proper y value. Or you can graph the function. I may also ask on this question something concerning the amplitude. And I may ask it in such a way where I'm asking, what is the amplitude of a function that has a maximum here and a minimum here? So for example, if I say there's a function with a maximum at, let me get a marker, at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and its minimum is at -1. So if I say I have a function that has something going on like this, a cosine function has something going on like this, what is the amplitude here? It goes 1, 2, 3, 4, 5, 6, 7, 8. It's 8 tall total, right? 1, 2, 3, 4, 5, 6, 7 tall. Now let's make it 8 tall. That way it's integer. 8 tall. 8. 1, 2, 3, 4, 5, 6, 7, 8. What's the actual amplitude here? If it goes from 6 to -2, if it's 8 tall. Well, the actual amplitude is actually only 4. That's where it's that's how tall each wave is. So it's centered here at 2, y equals 2, and it goes up and down 4 from 2. So I may ask you something concerning that as well. What is the amplitude of a function that's not necessarily graphed, but where I gave you the y values for it? All right, next item. Write the equation of the trigonometric function whose graph is shown. So sine or cosine first? Well, it starts in the middle, and it ends in the middle, its first wave. It has 3 points in the middle. 3 points in the middle. That is definitely a sine function, not a cosine. Because it goes down first, that means it's got a negative in front of the value of a. Again, amplitude is never negative, but it's got a negative in front of the value of a here. Because it's going down first. If it went up first, it would be a positive 3 sine of x. So again, I'm looking at this and I'm saying, well, it's the start of the first wave's in the middle. The end of the first wave's in the middle. It's got 3 points in the middle. We're going with sine. So it's going to be negative 3 sine x. Now, if I were to do cosine function here, a cosine should start at the top. This would be a good example of a cosine function. Start at the top, end at the top. Or it could start at the bottom and end at the bottom of its first wave as well. So a good example of a cosine function would be starting at the bottom. For example, maybe it starts here at 0, negative 3. Then it comes up to positive 3. Comes back down to, then it comes back down to negative 3 eventually. So those are my values there. And again, in between those, it goes through. So that'd be a good example of a cosine function. So that'd be a good example of a negative, what's going up and down 3. 1, 2, 3, negative 3 cosine of x. So that'd be a good example of. Now I would have to label the tick marks. This middle one would be pi. This ending one would be 2 pi. This would be 2 pi. This would be pi. This would be pi over 2. This one where it goes through the x would be 3 pi over 2. Would have to label them that. But again, that would be negative cosine. Positive cosine would start at positive 3. So the positive cosine would just be the reflection in the x-axis of that. So it would be here, and then it would be here, and then it would be up, 3, amplitude of 3, here, and then it would be up through here. There would be a negative cosine wave, or positive cosine wave, positive 3 cosine x, reflected in the x-axis. All right, so it's going to ask you something about identify the function given a graph based on its amplitude, positive and negative amplitude, as well as sine versus cosine. Sine is the one that's here. Cosine is this one. So I could have either one on a test here. Be prepared. All right, next question, moving along. And again, these are 5 points each, so far we're up to 60 points. So this would be question 12, pretty much on the test. We're up to 60 points so far, and there's going to be 15 of these. Question 13. Which one best describes? Choose an equation that best describes the graph from 0 to 2 pi of this particular graph. So I'm looking at this function and I'm asking myself, what is the period of this function? Well, this is one wave right to here. This is another whole wave, another whole wave, another whole wave. So I've actually got 1, 2, 3, 4 waves drawn. I really only want one wave. So in other words, all of this information past here is not going to be drawn for you on the test. And that is not useful. Just this is useful. So what is my wavelength? Well, that wavelength is pi over 2, or my period is pi over 2. And again, to get the period, you do 2 pi divided by b. So what I'm going to do is I'm going to set up an equation to figure out what b is, because that's what this question is asking. What's the value of b got to be to give me a period of pi over 2? So 2 pi divided by b must equal pi over 2. And I'm solving this for b by cross multiplication. So timesing this by 2 and timesing b by pi, 4 pi is equal to b times pi. So what is b? Well, dividing by pi, b is 4. This has a period modifier of 4. In other words, its period is 1/4 of the length of a regular sine function. A regular sine function has a period of 2 pi. Period of 2 pi. This sine function has a period of pi over 2, 1/4 as long. That's why there were 4 drawn here originally, because it was 4 times as long, or 4 times as short, 4 times as short, as it should be. Anyways, multiple choice questions, like we said before. Last multiple choice question. It's just going to ask you to identify the type of graph that you use for tangent. A tangent graph, again, is the one where it has the asymptotes on either side, and it has the function in it. It's just going to ask you what is the tangent function. Identify a tangent function. That's going to ask you to determine between positive and negative tangent. So here is positive tangent, tangent of x. Tangent of x goes this way. Then we have negative tangent that goes the other way, this way. And how can I verify what way tangent goes? Well, if I take my calculator out, this again would be 0. This would be x equals 0, y equals 0. So the tangent of nothing is nothing. These would be positive x values, and you could just use any small positive x value. And I'm in radian mode right now, so I should probably type in tangent, and I should use something like, well, if I use pi over 2, that's going to be undefined, because tangent of 90 is undefined. So maybe I shouldn't be using radian mode here, and I should be using degree, and use something like tangent of 30 or something, but let's use just tangent of something small like 1/4. Is this positive or negative? Positive. So as tangent goes to the right, it's still positive. And if it was a negative tangent, it would be negative. So if I stuck a negative in front of that, negative tangent, 1/4, that's now negative. So now when x is 1/4, y is a negative value. All this question is asking you to identify is between the difference of tangent and negative tangent. That's all this question is asking you. All right, moving along. Question number 15. Choose the equation that best describes the graph over the interval. Oh. Here we go. Here was the option for that last question. I didn't even notice that. So we wanted a positive tangent. There's a good positive tangent right there. It is modified by a 2. So I should be using this graph here because it was 2x instead of just x. But again, all it's asking me is to identify between tangent and not tangent. All right. Question 15 is also multiple choice concerning the concepts here on 12 and 13. It's asking, specifically on question 13. Specifically, it's asking you about identify the period modifier based on a wave that's graphed. So we'll have a wave graphed again, and you'll have to identify the period modifier based on the wave that's been graphed. Which again, you can do 2 pi over b equals the period length. Let me do another sample of that. Let's use a little card here, and we'll talk about it. Question 15 before I move on to this free response question. These other 3 are free response questions, by the way. 15, 16, and 17. So let me do one like a graph like that we just had. And we can look at it and we can determine what the period modifier is. So let's say I have a graph that's like this. Now, if it starts in the middle, that's going to be a sine. If it starts at the top or the bottom, that's going to be cosine. So let's say it starts in the middle. So it'll have 3 dots in its middle. Bam, bam, bam. Now, it could be going up or down, but let's say it goes up and then down. So here's my sine wave with an amplitude maybe of, I don't know, 2. Going up and down 2 units. Let's say these values here, well, I could do a lot of different things here. Let's say this ending value here, the end of the first wave is at pi. That would make this one pi over 2. This one here would be 3 pi over 2. 3 pi over 2, 4. And this one would be pi over 4. So what's my period? What is my period length from the start to the end of the first wave? Well, my period length is pi. That's how long the period is. From here to here is pi in length. So what does that mean about my period modifier? 2 pi divided by b is equal to pi. Because my period length is pi. Again, we're going to cross multiply. Well, there's nothing underneath the pi. That's just a 1. So 2 pi is equal to b pi. b is equal to 2. In other words, the value of b, the period modifier, is a 2 in this case. This function has half of the normal period a sine function has. A sine function usually has 2 pi. This one has just pi. So in terms of my equation, what would my equation be? Well, my equation would be y is equal to, the amplitude is 2, up and down 2, sine, the period modifier is also 2x. I'm not asking you anything about the phase shift or the vertical shift on this question, just the period modifier. If that ending value there was instead of a pi, if it was a pi over 2, this would change to a pi over 2. And again, b there would be equal to, just like the last question, where the period was pi over 2 here, b would equal a 4. b times pi equals 4 pi. If this ending value is a pi over 4, then that would just change to a pi over 4 there. And then b would equal 8. If the end of this first period is a pi over 12, that would change to a pi over 12 there. And b would be 24. 12 times 2 is 24 pi. B times pi, b pi, 24 pi equals b pi. B is 24. Again, part of the concept here that we're trying to get across is fractional work, which is why a lot of you find it so difficult. All right, so like I said, I intend to make each of these multiple choice questions worth 5 each. There are 15 total multiple choice questions. So that is 75 points from your test questions, from the multiple choice sections. So that is, again, 3/4 of the questions. The other questions are going to be specifically about these 3 types of items. There's going to be one where it asks you to describe what this graph is, another one where it asks you to graph, and another one where it asks you to graph. One specifically about a graph of a sine, and one specifically about a graph of a cosine function. So one sine graph and one cosine graph, one of each. All right, so use complete sentences making conjecture about y equals -4 sine 2 pi times x plus pi minus 2. So these will be worth, like I said at the start of the review, I'm going to make them worth 8 each. So what I'm looking for here is, it says use complete sentences, but I'm looking for the amplitude, which is 4. The phase shift, which is -pi, not positive. Remember, it's opposite of what's written. The vertical shift. And I'm not necessarily looking for you to write down the period modifier, the value of b. I'm actually looking for what the period is. So b is 2, yes, b is 2. That's nice to write that down. And again, I'm going to make this worth 8, so this will be 2, 4, 6. That's 7 out of 8. If you want the last point, you're going to have to tell me what the actual period is. So I'm actually looking for the period, which is 2 pi divided by b. So 2 pi divided by 2 in this case is equal to pi. So those are the items I'm looking for, these 4 right here. You don't have to include b if you don't want to. B is included in the answer for the period. In other words, b is optional. And if you want to use complete sentences, you would say the amplitude is 4. It shifts left pi down 2 with a period of pi. That would be the way to describe this with complete sentences. Question 16, graph, sine and cosine. All right, so A is equal to 4. B is equal to 1. H is equal to 0 because there's nothing with x in the parenthesis here. Remember, H should be with x in a parenthesis, not following x, but with x. With x in the parenthesis. K is -2. So A, B, H, and K. I also have to write down what my period is. Period 2 pi divided by B. Notice I made B a 1 here. So expect to have one function where you have the period of a 2 pi, where b is 1. And then another function where it's not a period of 2 pi, where it's been modified a little bit. All right, so the sine function, it should have the start of its wave at h comma k. h comma k. So 0, -2 is the start of the wave in this case, the start of the first wave. 1, 2, -2. And it should end its first wave at h plus the period, comma k. So whatever the period is, I add it to h, and I keep the same vertical shift here. So the period here is 2 pi. Since I started at 0, I had no horizontal shift or phase shift. It's going to be 2 pi, comma, -2. Now I'm looking at my grid. I can do my tick marks however I want. I can go by 3s, I can go by 4s, I can go by 5s. Let's go by 3s. So every third one I'm going to make a tick mark. 1, 2, 3. 1, 2, 3. 1, 2, 3. I could have went by 4s if I wanted as well. So I started here. I end on my 4th tick mark because I want 4 even sections on my wave. And that tick mark is going to be labeled as 2 pi. 2 pi, comma, -2. 2 pi is this tick mark. My amplitude is 4. Now this 4 is preceded by a positive sign. So it's going to go up first before it goes down. So for my first tick mark, I'm going up 4 from the middle of the wave. Again, this is the middle of the wave, the center of the wave. There's the center. So in other words, it can fold over that, and it will be symmetrical with that. So go up 1, 2, 3, 4. So the starting portion of my wave is here. It went up 4. That's the crest. Then it comes down 4. Back to the middle. There's the middle of the wave. Now I can't fit on the bottom. They're going down 4 for the next portion of the wave. So I'm just going to add a tick mark here underneath because it should go 1, 1, 2, 3, 4 down. There we go. Before it comes 4 back up. There's my wave. Sine again should be centered at its value of k, its vertical shift. It has 3 values there. Its wave does, its first wave. And it should have one above and one below. It goes above first if it's got a positive here in front of a. If it's a negative, it will go below first. And again, that value of a tells you how much to go up and down from k. So from -2, I'm going to go up 4 to +2. I'm going to go down 4 to -6. And these other ones are centered at -2 along the center of my wave. All right, so there's my sine graph. Again, that's 8 points. I will assign partial here. So if you provide for me the values of a, b, h, and k, as well as the period, I will probably assign half the points there. Then I'll assign another couple points for the start and the end value. And then the rest of the points will be assigned to the tick marks. The tick marks as well as the curvature on the wave. I have forgotten to put the tick marks here. So I would be taking off 1 point here if it was on the test, because you didn't put the tick marks. You didn't label them. So this is pi. This is 3 pi over 2, and this is pi over 2 right here, this first tick mark. How did I know that? Well, this is 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. And then halfway between pi and 2 pi is 3 pi over 2. In other words, I could times this by 2, and I can make it 2's. So this is 4 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. It's going by halves in this case because the period is pi. All right, moving along. Cosine graph. A is equal to 1. A should be here. And again, amplitude cannot be nothing. Amplitude has to be something. It has to be at least 1, because if it doesn't have amplitude, it's not a wave. That value in front of x is a b value. B is 4. That value following x is an h value. H is pi over 2, and again, it's opposite, just like the parabolas we did in the past, or like point slope form. And k is nothing. So my period, 2 pi divided by b, pi over 2. Again, I will probably assign half of the points here if you just write down those values. A, B, H, K, and the period. I'll be making these 4 each. 4 each, 8 each. So it'll be 4 for that, then the other 4 from the graph. All right, cosine starts at H still. But this is now k plus the amplitude. Because cosine starts at the top or bottom of its wave, depending on if the amplitude is negative or positive. In this case, the amplitude is positive, so it starts at the top of its wave. So h is pi over 2. K plus a is 1. So I'm going to make a tick mark, and I'm going to label it as pi over 2, comma 1. Again, I can go every third, or I can go every fourth. It doesn't really matter. So pi over 2, comma 1. That's where I'm starting. It ends. Its first wavelength ends at h plus the period, and it ends at the same y value it starts with, k plus the amplitude. So that is again 1, because k is nothing and a is 1. H plus the period, I'm going to take pi over 2 plus pi over 2. Pi over 2 plus pi over 2. So they're both fractions over 2 already. So I can just add them, pi over 2 plus pi over 2, that's 2 pi over 2. I can leave it as 2 pi over 2, or I can make it into a pi. I don't really care how you leave it. But that's the ending tick mark. So, again, I need 4 even spaces here for my wave, 4 even portions. I'm going to do every third one as a tick mark. 1, 2, 3. 1, 2, 3. So there's 2 even portions. 1, 2, 3. There's 3 even portions. 1, 2, 3. There's the 4th portion. 1, 2, 3, 4 portions. Because I need a top, a middle, a bottom, a middle, and the top for my wave. That last portion I'm going to label as a pi. This tick mark is pi. So at pi, I'm at 1 again. So my wave is going to come down 1, down another 1, up 1, and then up to the top. So there's my wave format for my cosine wave this time. That would be 7 out of 10, or 7 out of 8 points. They're worth 8. The final thing to do here is to label the tick marks. So this is pi over 2, this is pi. So I'm not going by halves this time, because pi over 2 plus pi over 2 is equal to pi. Not going by halves. What am I going by? I need, again, 4 even tick marks. So consider this. If I times this by 4, I get 8s. If I times this by 4, if I times this by, I can make this into 8s as well. 8 eighths. So this is 4 eighths. This is 8 eighths. So this is 4, 5, 6, 7, 8. So this is 5 pi over 8, 6 pi over 8, and 7 pi over 8. Again, to get these fractions in the denominator, it's 1/4 each time. So 1/4 of a half is an eighth. So this is 4 eighths, 5, 6, 7 eighths. 1/4 of 2 pi is a half. 2 pi over 4 is pi over 2, so that's why this is a half. 2 halves, 3 halves, 4 halves. I understand difficulty with fractions, ladies and gentlemen. But we do, that is why the reason that we're teaching this one. That is one of the reasons we do this section. Anyways, so 8 points each on those. And again, that's 18 questions total. There was one that wasn't labeled here that I was talking about with, evaluating the sine and cosine of a particular value. For example, we'll type it in the calculator right here. Evaluating what the sine of pi is. Pi is nothing. Remember to be in radian mode. If you're in degree mode, you're going to get this wrong. Or what is the sine of pi over 2? Sine of pi over 2 is 1. Or what is the sine of pi over 4? Well, this one's going to be a decimal value, right? You're already aware that this one's a decimal, right? Because this one's not a nice number. But you can figure out what it is by the decimal. That's the square root of 2 divided in half. Because 1.4 is the square root of 2. Square root of 2. If I divide it in half, I get 0.707. So the sine of pi over 4 would be square root of 2 over 2. Anyhow, so there'll be a question about that from that unit circle. Don't forget that's on the multiple choice section here. I hope this helped you with the review, and I hope this helps you to understand the material that I intend to test you on and not to be super stressed about it. Again, I do want you to do well with this test. Good luck.